So here we have this right circular cylinder, or this cylindrical tank, with a radius of 3 feet, and it's got a height of 8 feet, and it's full of water. How much work is it if the water is pumped out of the top of the tank? Well, water weighs 62.5 pounds for every cubic foot that you have. That's one piece of information that we need. Now, suppose that the water is being brought up, and at some given point, we've got this is the length of x that it needs to be brought up. And basically you could view it as if you have, imagine like a quarter or a dime that is circular, but it's not very tall. So this height right here could be delta x, and then you just got this circular slab right here. So this little piece of water needs to be taken out. So what's the volume of that? So this is a little disc, and the volume of a disc is pi radius squared times its height. So that's going to be the volume of this little red disc right here. Well, the radius, that's no secret, it's 3. And its height is going to be this little delta x. So the volume of that's going to be pi and then 3 squared and then delta x. Then how much force is this little disc, or how much does this little disc weigh? Well, this would be in cubic feet. So if you multiply it with this, then the cubic feet will cancel. So the amount of force is equal to multiply 62.5 times, and then this would be 9 pi, and then delta x. Now we have to have these discs starting at the bottom and then all the way up to the top, and add up how much force is there in total. So add up the 62.5 times 9 pi, and then when you write down the integral, the delta x becomes the dx. And then we need to go from down here, which would be when x equals 8, to here when x equals 0. Okay, so, I forgot the distance, sorry. So the distance is x, the distance that you have to travel, or this circular cylinder, red circular cylinder has to travel. So I forgot that part, times the x, distance. So that way it's force times distance. So this 9 pi and this 62.5, that's equal to 1767. So 1767.146. So that I could factor out and then find the antiderivative of x. That's going to be x squared over 2. And then evaluate that from 8 to 0. So when you substitute the 0, that's going to be 0. And then minus the 1767.146. And then this is going to be 8 squared, so that's 64, but then cut that in half, so it's 32. So then multiply that by 32, and it's 56,548.668, and the units would be foot-pounds. It's the total amount of work. And technically, because of this, it's negative, which is just orientation. Like if you're putting the water in, it'll be positive. If you're taking out, it's negative. But that just basically describes the direction. The amount of work is actually 56,000 foot-pounds.